In this lecture, we'll be talking about hyperparameter optimization. So what is hyperparameter optimization and why do we do it? The answer is that hyperparameters are similar to parameters when we train models. However, technically, each hyperparameter determines a different model, whereas a parameter is part of the model. Conceptually, however, hyperparameter optimization is not that different from training a model, but basically we are training many models and then selecting the best one. So while I set up here, our goal is to specify the possible models that we will be considering, that is the parameter range. For instance, for a support vector classifier, we have a parameter C, and we can choose what values we would consider as part of our collection of models. In this case, we have here powers of 10. We can also consider possible gamma values and possible kernels. And geometrically, this space, in terms of math, can be thought of as a grid. Each combination of parameters, for instance, let's say 0.01 for C, linear kernel, and the default value of gamma, form one point inside of the grid, like so. And our goal is to figure out which of these points, each representing a model, is the best one. Unfortunately, since each point is a model, each point requires going through a training phase, which is very time consuming. In the ordinary grid search, we go through all these points anyway, and then find the best one. In this case, here is the combination, the winning model, which we have found. Sometimes computational resources and time are limited, and we go for a different strategy, such as a randomized search, in which case we travel around this grid at random, picking this model or that one or this one randomly. Geometrically, here is our grid again. For instance, this could be C being 0.01, C is 0.1, C is 1, and then the ideal C is perhaps in between these, and we have not included it, but nonetheless, we're getting close. In the randomized search, you can see it is possible that we would get the right answer, but we could also end up wandering completely at random in the incorrect direction. There are other more clever strategies, such as successive halving. This is similar to genetic algorithms, if you're not familiar. Basically, we generate many candidates of parameters and then eliminate the least successful ones, say the bottom 50% get eliminated, and then we produce a mating of the successful ones. That's in the genetic algorithms, and a similar situation happens in hyperparameter search. There are other search techniques, and of course many more in the literature, such as Bayesian optimization, in which a probability distribution generated and adapted as we go along, and it determines where we explore. So if the probability is high, then we are more likely to go into the high probability area, and if low, then we are likely to avoid it. So with this, you should have a good grasp of the basic ideas behind hyperparameter search, and of course the code is available to you in your critical thinking assignment. You will get to utilize some of these search techniques. So good luck. See you next time.